Okay, so here's our first example, and it asks us for the following exponential function. So we have y equals 3 times 2 to the exponent x minus 1 minus 4. The first part asks us to sketch the function, and then part B, state the domain, range, and equation of the asymptote, and then part C, whether the function is increasing or decreasing. So first thing I need to do is figure out what my base function is in order for me to figure out what the key points are going to be and what the graph should look like. So the way to figure out what the base function is to look at the number that has exponents applied to it. And I can see clearly here that the exponent that I'm looking at, which is x minus 1, is being applied to a base of 2. So what this tells me is that my base function is y equals 2 to the exponent x. So y equals 2 to the exponent x is my base function. Okay? So what the other thing it tells me is that 2 is not a transformation. This is actually the graph that I started with, and now all the other numbers, so the 3, the minus 1 in the exponent, and the minus 4 at the end, those are actually all the transformations that are applied to y equals 2 to the exponent x. So that's a good place to start. If you wanted to also, you can try to figure out where the horizontal asymptote is moved, and that'll just help you create a barrier in your graph, since the graph can't pass through the asymptote. And so I think I'm going to do that next. And so normally my horizontal asymptote is at y equals 0, but it looks like the graph has been shifted down 4 units. So that tells me the horizontal asymptote will now be at y equals negative 4. So it's moved down 4 units, so it's moved to y equals negative 4. And now from here, I can find my key points and apply different transformations to it and then try to graph it from there. So that's what I'm going to start to do. So I'm just going to create a little table here. And so I'm going to choose my x values, and y equals 2 to the exponent x is my base function. Okay, that's the function that all the transformations are applied to. And the values of x that will make this a little bit easier for me to work with are negative 1, 0, and 1. And my values of y that correspond to these particular values of x. Now remember that my base function in this case is 2 to the exponent x. So I'm going to look at 2 to the exponent negative 1, 2 to the exponent 0, and 2 to the exponent 1. I'm going to substitute in these different values of x to solve for my corresponding value of y. And so 2 to the exponent negative 1 is 1/2, or 0.5 in this case. And 2 to the exponent 0 I know is equal to 1. And 2 to the exponent 1 is equal to 2. So here's our y-intercept again, so that hasn't changed. That's one way to confirm that you've done your work correctly. Okay, now I'm going to apply the transformations to it. So I'll set up another table here. And I'm going to start by looking at my horizontal transformations. And the reason why I'm doing that is because all the horizontal transformations should appear in the exponent part. And so aside from x, the only other number that's there is a minus 1. And I know that based on my horizontal transformations, it's always opposite to what it looks like. So this is actually a horizontal shift to the right one, which means all my x values are increasing by 1. Okay, that's the only transformation that's in the exponent, where the x is. Okay, in terms of vertical transformations, I have a 3 at the front and I have a minus 4 at the end. So that indicates a vertical stretch by a factor of 3 and a shift down 4 units. So there's all our transformations. Again, the only value that's not a transformation is the base of the exponent, which actually indicates to us what our base function is for our exponential function. Okay, so x plus 1, looking at our values of x, negative 1 plus 1 is 0, 0 plus 1 is 1, and 1 plus 1 is 2. That was easy. Looking at our y values, 3 times a half is 1.5, and minus 4 is negative 2.5. 3 times 1 is 3, minus 4 is negative 1. And 3 times 2 is 6, minus 4 is 2. So there's all of our key points.